So we are doing rules of differentiation. Let me rotate my screen. Charger. Okay, so differentiation is very interesting. Algebra should be very clean. Right. So let's go to our source material, the Aquila book.
Okay.
Let's do one equation. Let's see. X squared minus 1, 2x squared plus 1. Or let me see if I can take something from our current series. Let's see, I have some contents here. Mr. Quotient rule. Mr. Quotient rule. We have composite functions. Okay, let's do one more quotient rule question and move to the composite functions. So
Okay.
y equals 3x. I don't know if you solved that one. 3x squared or something. Then 3x exponent 4. 3x exponent 4. Let's do 3x squared. Going to use the question. Y equals 3x squared minus 2x all over x cubed plus 1, right? So right here, solution.
I think you've done that too.
We've done this one, eh?
Yes.
Okay. Then let me see if I can get more from Aquila. I want the ones which are quite challenging. It seems the ones here okay. So let's go to the composite functions then.
Okay.
So yeah, I'll be checking your book.
Okay.
So composite functions. Now when we talk about composite functions, it's basically a function within another function. Right? So that's what we'll be using
Okay.
chain rule. Right? So a function like y equals 2x squared plus 1 raised to the power 2, right? Find the y dx. Right? So in this case, dy dx, or better still, there are two techniques you can use to do this, right? One, when you are using this technique, let y equals what? U raised to the power 2, where u is what? 2x squared plus 1. Are you okay?
Okay.
So in this case, anywhere you see the you see this one, you've made the u represent this element. So things here, everything in this one. right? So it has become a function in another function, right? So du dx
Okay.
becomes 4x, right? Then the y du will also become what? 2u. So in order to find the y dx, call something a chain rule. You start from dy over something times that same something over dx. So the linking the something is the du. Are you okay?
Okay.
So now let's go and look for dy du. And dy du is what? 2u times du dx. That is 4x. When you multiply them, you are getting what? 8ux. But u is what? 2x squared plus 1. So this becomes 8 times 2x squared plus 1 times x. So basically 8x times 2x squared plus 1. You get it?
Yes.
And this one, you can simplify it as what? 16x cubed plus 8x. Are we okay?
Yeah.
Very good. Another approach you can also use is that if y is the same as 2x squared plus 1, right? Y dx will be, now see everything here as a, right? See everything here as what? A square. Are we okay?
Okay.
Now how will you differentiate a square? You just bring the square in front. That's the 2. Bring it in front. It becomes a raised to the power 2 negative 1. 2 exponent 1, right? If you have y equals a square, you differentiate, you're getting 2a, right?
Yes.
Very good. That's what we are doing over here. So the 2 comes in front. The 2 moves from here over here to become a coefficient. Then this maintains 2x squared plus 1. Maintains with the exponent of what? 1. Then you also multiply by the differential of the inside. When you differentiate what is in the bracket, what will you get?
2
4,
x. 4 x.
right? Then you simplify this.
Mm-hmm.
So this time this gives you what? 8x times 2x squared plus 1. Then it becomes 16x cubed plus 1. Sorry, plus 8x. Are we okay?
Yeah.
So these two techniques, this one is a chain rule. Chain meaning something connecting something. You see, chains are connected by themselves, common elements. Now the chain rule become very important when you do applications of differentiation, right? We're doing applications
Mm.
of differentiation. That's why it's good to know all these two techniques. But the second one is shorter and faster. When you're dealing with the algebra approach. But when you go to the application, the chain rule will be very important, right?
Okay.
Another classic example, you have y equals the root of 3x plus 2. Find y prime. Y prime basically means y dx, right? So y equals 3x plus 2. This y can also be rewritten as what? Y equals 3x plus 2 raised to the power half,
Mm.
right? Now this now
Okay.
becomes a composite function, a function within another function. So dy dx becomes the half will come forward here. Differentiate what you have in the inside. When you differentiate what you have in the inside, what do you get?
Get 3.
3. Very good. Then bring the whole bracket element. Then half minus 1. When you do half minus 1, what do you get? Negative half.
Negative half.
It becomes negative half. So the final answer here becomes 3, or let me say divide the x, becomes 3 over 2, 3x plus 2 to the power negative half. Whenever we are dealing with negative exponents, it becomes fractions below. So it becomes 3 at the top all over 2 the root of what? 3x plus 2. I believe you know that the root is the same as what? Everything raised to the power half.
Yes.
This time, because of the negative, it's no more becoming negative downward. It becomes positive downwards. Right?
Yeah. Yes, sir.
So it becomes dy dx 3 over 2 root 3x plus 2. The reason why we are sending it back to root is because the question was given in terms of sets. So when we are trying to
Okay.
give them that solution to in terms of sets, we can also use the chain rule approach. All the time, learn how to use different techniques in solving problems, right? So in this case, if you
Okay,
use the
sir.
chain rule, y equals this 3x plus 2, right? So let
Okay.
u be 3x plus 2. Now, if you let u become this one, this means that y is what? Square root of u. So now differentiate both elements, du dx. Where is the pen? Du dx is going to be what? When you differentiate this function, what do you get?
We get 3.
3. And dy du, mind you, the square root is half. So if you are differentiating, it becomes half
Half
u exponent
u
negative half.
negative half.
Now with chain rule, you can cross multiply and what? You are good to go. Right? No,
Okay.
no, that's not the case. Sorry. Is the y? Yes, you just multiply these, not cross multiply. It's better I write the formula so that I don't miss my way. So chain rule y dx is dy over something times something about dx. And that something is a common element related to dy in dx. So that's du. Are you okay?
Yes.
So what is dy du? That's half u exponent half, negative half, times 3. Right? That's the value of dy
Okay.
dx.
Okay.
Then eventually you substitute what the values. So half, let me 2 root u. I think this is convenient, times 3, right? And we know that u is what? This is u, right? So we just come and substitute. Divide dx becomes 1, or let's say 3 multiplied 1, giving you 3.
Okay.
So that becomes 3 over 2 root u. U is 3x plus 2. And it boils down to the same answer. And this is just the alternative approach. You get it?
Easy.
So you see that if you're using the composite function, it's quite faster, but
Yeah.
it's you just have to know when to use it, and the one your memory will record easier.
Okay.
Okay, so that's about it for the composite functions. Whenever you get a function, you can break it down with what chain rule, or you can use what do we call it? The composite function approach. Now, before
Okay.
we do the implicit function, let's do partial fractional decomposition. When you use partial fractions to break them down. So use of partial fractions. Rational functions with two or more factors in the denominator may be differentiated by expressing the first differentiated by expressing the function into partial fractions. So if you have a partial fraction like this, you can't differentiate easily unless you break it down into partial fractions. Then differentiate each term by each term using the quotient rule approach. So let's do something like this.
Okay.
I'm surprised we don't have partial fractions inside the Acron series. Okay, so 1 over difference of two squares, right? So partial, how do I move it? Let me check if what I'm writing is very good. So minus 1 plus 1 changes 1 to minus 1, right? If you want to find the ydx, now if you want to find the ydx for this function, how do we do that? So break this one down into partial fractions, right? So for partial fractions, 1 over x minus 1, x plus 1 can be written now as what? A over x minus 1 plus b x plus 1. And with partial fractions, whenever the down the denominator is a linear function, the numerator becomes a constant. When the denominator is a quadratic function, the numerator becomes a linear function, and so on and so forth, depending on the. It just has to be a proper fraction where the numerator has a lower exponent and the denominator has a greater exponent. Multiply through by LCM. By LCM. So the LCM is this one, x minus 1, x plus 1. When you multiply it by itself, it will vanish. Then you get 1 on the left hand side. Then these ones eventually cross product, right? Because when you multiply through by this LCM, this x minus 1 will cancel minus 1. And you'll be left with what? X plus 1. So a x plus 1. Please, are you getting what I'm saying?
Easy.
X minus 1, right? Then when x is negative 1, this becomes 0. the a part becomes 0. So 1 will be equal to a negative 1 plus 1 plus b negative 1 minus 1. So 1 becomes b times negative 2.
Okay.
And 1 over negative 2 or negative half becomes the value of b. And x is 1, when x is 1, basically you are just equating these factors to 0 to find the value of x that you substitute into the function. So when x is 1, 1 equals a 1 plus 1 plus b 1 minus 1. So 1 becomes a times 2. So half for the value of a. Now go and rewrite the function. It becomes y equals half, right? Because the value of a is half.
Okay.
So the half becomes 1 over 2 over here, right? But the half, the denominator will come down. Are we okay? Instead of writing
Yes.
1 over 2, writing x minus 1 like this denominator will eventually come down, right? It becomes 1 over 2 x minus 1 plus, there's a negative here, right?
Okay.
It's going to affect this one, becoming negative 1 over 2 x plus 1. Now you have your function. So now you're going to find the y dx. Are we okay?
Yes.
So now in this case, can you differentiate them easily? Are you going to use the quotient rule, or what rule are you going to use? You can rewrite them because the half is a factor. So y can be written as what? Half x minus 1 raised to the power negative 1 minus half x plus 1 raised to the power negative 1. We are changing them from this to this so that we can differentiate easily. Right? We are applying indices.
Okay.
If you have 1 over 2a, it can be written as 1 over 2 times what? 1 over a. We know that 1 over a becomes what? A raised to the power negative 1. So that's the technique I'm using to change these expressions. Are you okay?
Yes.
So now we can differentiate. dy dx becomes, this negative comes to multiply, you get negative half. Subtract minus 1 from the exponent, giving you negative 1, negative 2. This negative multiplies this negative, becoming positive half x plus 1. Subtract 1 here, giving you negative 2. Negative 1 minus negative 1, negative 2. Now we can send it back into fractional approach. It becomes negative 1 all over 2 x minus 1 squared plus 1 2 x plus 1 squared. And that becomes your final answer, dy dx.
Okay.
So let's go and look at the solution. Wow. Yes, it's a different solution than they had.
Okay.
Negative 2x over x minus 1 square, x plus 1 square. Okay. I don't know if we did something wrong. Let's check the solution again. We just wrote the answers. Let's look at the example. They brought the negative 2 upwards. They differentiated them step by step. Okay, I think you made a mistake somewhere.
Okay.
It's a quotient. It's a composite function. Apologies. So you have to differentiate the inside. But when you differentiate this one, you get one. This one, when you differentiate inside, you get one. These are composite functions. This one. But when you differentiate you see, the composite function says that differentiate the whole function times differentiating the inside. But when you differentiate inside here, you get one. When you differentiate inside here, you get one. So this is still correct.
Okay.
Or let's see. So I have half, right? X minus 1 is equal to negative 1. A half comes, it multiplies this negative 1. I differentiate the inside, which is 1, and keep the outside negative 2. This becomes half times x minus 1 squared, 1 over 2. So I still don't see negative. I still don't see, unless maybe we are factorizing the halves out. I don't get their solution. So the solution is what? Negative 2x all over x minus 1 squared, x plus 1 squared. Or they are using product rule. I don't get it. I don't get it. Even
We should try productivism.
if we subtract if we subtract this one,
Mm.
subtract this, if we factorize this one out, we left with 1 over x minus 1 squared plus 1 over x plus 1 squared, right?
Okay.
And even if this one we want to factor something out, it's like difference of two squares all squared. Unless maybe they didn't use partial fractions. They are just using difference of two squares right from the beginning, 1 over x squared minus 1. And it eventually becomes x squared minus 1 all over negative 2 and negative
Okay.
1. When you differentiate, you get negative 1, 2x times x squared minus 1 to the power negative 2. This gives you negative 2x um, over x squared minus 1 squared, right?
Okay.
Let me go look at their solution. Negative 2x x squared minus 1 squared. Then eventually they use difference of two squares. Negative 2x x squared minus 1 x squared minus 1 becomes x plus 1 x minus 1, another x plus 1, right? Then it becomes x plus 1 x minus 1 squared. But they are talking, I don't know why they are talking about partial fractions. We are using a different technique to solve to get the partial fractions. Or unless I'm doing the partial fractions wrongly. But do you understand the approach that I use over here?
Yes.
We are using the what? Uh, we are using the difference of two squares instead of separating them into partial fractions. We are using difference of two squares. Well, I'll later check again. I'll check again. I'll use
Okay.
fractions to solve. So you should be getting the same answer. The down part we have it correct. the x plus 1 square, x plus 2 square. But they multiply,
Mm.
becoming a product, man, is what I'm. Let me um, partial fractional section. If I'll get the solution. The composition of what 1 over x plus 1, x minus 1 is actually this one. 1 over 2, x minus 1, 1 over 2, plus 1, and our partial yes, the position correct. Okay, so they say the answer is correct. Step 1,
Okay.
solution. Perform a partial fractional decomposition. That's what we did. Differentiate the decomposed fractions. That's what we did. Simplify. Okay, so you have to simplify again. Oh, it's too long. I get okay. So the only part that we were left to do is the simplification. You have to simplify with an LCM over here. You get it?
Okay.
So you have to simplify with the LCM. The LCM we multiply the denominators, then we cross them out. Okay, I think I get it now. So I think our technique is correct. What we have to do is find the LCM of this. This becomes 2x minus 1 squared times 2x. No, it's not times 2 because 2 is common to both, right? 2
Yes.
is common to both. So let's bring this. Oh, x plus 1. Right. Now, this becomes negative because of the negative here. This times what will give you everything that we have here. This times the opposite element. That's x plus 1 squared, right?
Okay.
Plus this one times what will give you everything here. It is times only this one, right? Because 2 this thing. We already have 2 x plus 1 here. So to get the other one, you have to multiply by this. This becomes plus x minus 1 squared. Let me check if I'm on the right path. Let's say plus. Okay, because of the minus, I can rearrange them. Okay, so let's open the bracket. We open the bracket. Negative x squared plus x plus 1, right? Minus x squared plus x squared minus x plus 1 all over 2 x minus 1 squared x plus 1. The part as negative x squared minus 2x minus 1 plus x squared minus 2x plus 1 all over 2x minus 1 squared x plus 1. This negative will cancel this positive. 2x and 2x become 4x. 1 and negative 1 will cancel. And now I'm going downwards to the rabbit hole. This becomes negative 4x all over 2 minus 1 squared squared. Then 2 equals here 1, 2 equals here 2, giving you negative 2x all over x minus 1 squared, x plus 1 squared. So you see, if you're using the partial fractions, it's very long. But the same question, you could have used the difference of two squares to simplify everything and work our way out. But the reason why we are doing this partial fractions, you can get some functions you cannot simplify. Some functions you cannot
Okay.
simplify easily unless you break them down to partial fractions. Okay, so that's the reason why we are going through this. Some of these functions you can break them down easily, but you see, all these functions they are quadratics. The denominators they are quadratics. You can resolve them with your quadratic calculator, multiply them, expand them to be simple. But not all partial fractions can be simplified just like this. Let's try and do the second one. X over x minus 2, x plus 2. Because if you want to use the partial fraction approach, it should be the last resort. So imagine if we have only the last resort here. Y equals 2x over 2x minus 1. Hope you are writing.
Yeah. Yes.
Now, in such a situation, what do we do? Should we decompose the fraction or we should multiply the denominator to get the quadratic function? Hello.
Okay.
Now, this one, we have two techniques we can use. We can use a partial fractional decomposition, or we can just simply expand the bracket, right?
Okay.
So if you expand the bracket, something like y equals 2x over this, you get 2x squared minus 6x minus x plus 3, right? Then you use the vin du dx. It becomes what vin. Remember, quotient rule. So u equals 2x. Vin equals 2x squared minus 7 plus 3. 7 is this minus this, right? So the u dx comes to a vin dx becomes 4x minus 7 equals multiply, right?
Okay.
All over vin squared. Cross multiply, subtract. Remember,
Yes.
so dy dx, it becomes vin du dx. So it's the vin that will come first. Vin du dx, this one, then multiply to
Yes.
it. That becomes 2 times 2x squared minus 7x plus 3 minus u divided dx 2x 4x minus 7 all over v squared 2x minus 1 x minus 3. Or I should expand the whole v squared. expand the top. 4x squared minus 14x plus 6. 8x plus 14. The 14, that's the 14x. This is all about 2x minus 1, x minus 3 all squared. Then you have a quadratic function of 4x squared minus 8 all over. Let's go and check if that's the answer behind it.
Okay.
Now they used partial fractional decomposition to get the answer. Right, x minus 2 square, x minus 3 plus 1. What am I doing? Doing number 2. Oh, number 3 rather.
3.
So 5, 2x minus 1 square. This is about 5, x minus 3 square. So I think, okay, um, I'll confirm with AI. But let's use the partial fractional decomposition and see if it will work.
Okay.
My pen is not coming again. The pen is on no battery. Oh, let me use this pen. I can't use this pen after 1 hour. The pen is on low battery. It's not on low battery. So I don't know why it's not connected. Ah, the app. I could close it. You say something.
Mm. No, you're actually not saying something.
Come again.
I thought you're asking if I'm saying something.
I hear some batteries like that.
No.
Everything is made short of listening. The answer.
Mm.
Oh, it's taking long. The app is loading slowly. Sometimes you saw the thing, but they'll say, oh, it's not in your book, it's not in the marking scheme.
Mhm.
Because in the marking scheme, they use something else. Calculus is very interesting. So let's use the partial decomposition and see. 2x
Okay.
over 2x minus 1, x minus 3 should be equal to a over 2x minus 1 plus b over x minus 3. When you multiply through by the LCM, you're going to get 2x equals ax minus 3. This is what should be plus b x minus 1. So when x is 3, basically equate these functions to 0 to get the values of x needed to make it easy. So when x is, or let's say when x is 1 over 2, right? So it means 2 times what? 1 over 2 becomes a 1 over 2 minus 3. When you put 1 over 2 here, eventually you get 0 because 2 times 1 over 2 minus 1. This and this will cancel, giving you 0. 1 minus 1 is 0, affecting the b. That eliminates the b. Are we okay?
Yes.
So 1 equals a. Whenever you have a fraction in the whole number, multiply this and this. You're getting 1 minus 6 all over 2. It becomes 1 equals negative 5a over 2. So 2 over 5 negative becomes the value of a. Right? 2 multiplies here. The 5 comes to divide. Are we okay?
Yes. Sir.
Now, when x is what? 3. When x is 3, get 2 times what? 10 equals a 3 minus 3 becomes 0 over here. So just put in the b. b 2 times 3 minus 1 equals b 6 minus 1. 6 equals 5b. So 5 equals b. And then rearrange it. So 2x over 2x minus 1 x minus 3 becomes negative 2 over 5 2x minus 1 plus 6 over 5 x minus 3. Now let's do the differentiation. So y becomes negative 2 over 5 and send the numerator up plus 6 over 5 x minus 3 raised to the power negative 1. So dy dx. And we are going to use the quotient composite function. This negative multiplies this negative, giving you positive 2 over 5. Differentiate the
Okay.
inside bracket, you'll be getting 2, right? Then the function itself, 2x minus 1. This to the power negative 2 because you are subtracting 1. Divide the x differentiation, old exponent multiplication. Divide the x differentiation, it reverse exponent 1 subtraction. Now this negative comes to multiply 6 over 5, giving you negative 6 over 5. Differentiate the inside, you get 1. Then x minus 3, all raised to the power negative 2. So you eventually get 4 over 5. Then this negative will come down. So let's rewrite the fraction again. 4 all over 5 2x minus 1 squared minus 6 all over 5 x minus 3 all squared. This was the first technique we're using. Let's go and check it. That's how they had their answer. Yes. I are you okay?
Yes, sir.
Now I'll do one on your own. So you say alright, you say alright. Which one do you want? The second one or the fourth one?
Any of them.
Do the fourth one. 3x minus 1, x plus 2.
You
Let
don't
me
think
go.
it's any of them.
Let me,
Screenshot.
let me remind you. So right here you can see that they are still fractions, right? But quotient rule may not be an appropriate measure of solution. Okay, let's do the last one. Then we can call it a more calculative let's before it to work.
Okay.
I didn't drop the YouTube link in the okay, let me write it. Then
Okay.
3x minus 1, so y equals 3x minus 1 over x plus 2, 2x minus 1, x plus 2, 2x minus 1. Find y x. So you write the question again. 3x minus 1 over x plus 2, 2x minus 1. Okay, now, so you talk alright, you talk alright.
Okay. So u is equal to
U, are you going to use U? You can't use the quotient rule. You have to use the partial decomposition. You have to take partial
okay.
fractions. So break them down in partial fractions.
Okay. So a is equal a over
No, write the function before you say the A. You have to write that
okay
3x minus 1.
x x minus one over x plus 3 x minus 1 is equal to
Yeah.
a over x plus 2 minus 1 over
1.
2x 1 over
No, you are not using 1. You are using B.
b over 2x minus 1.
So what do you do?
You take the x 3x minus 1 is equal to a times x plus 2 minus b times x minus 2. You know the is the instead of x plus 2 is 2x minus 1.
Okay, very good.
Yes,
Good, you identify your mistakes.
yes. And the b is x plus 2.
So what else?
So when x is negative 2, so 3x, no, 3 negative 2. 3 times negative 2
So 3 times negative 2 minus
3 times negative 2 minus 1 is equal to b is equal to negative b, or actually negative b bracket open 2 times
X is negative 2. You say X is negative 2. When you put the negative 2 here,
negative 2.
everything will be 0. You have to put it in the A.
Okay, that's it. Then you have to use then I think the x have to be negative half.
Yes, you can use 2, you can use half. Just you have to know the values of X you are using. X equals half.
Okay.
X equals what? Negative 2. Because you have to equate these factors to 0. So that
Okay.
just know when the one you want to use first. You have
Okay.
to use the half.
Yes.
So when X is half,
Yes. To retain the negative to okay. To a bracket open. Okay. 2 times half minus 1 bracket close.
minus B. If they put the
Minus
half
b.
inside everything before you put
Okay.
one, that would be the 0.
Okay.
So if this cancels this, you can simplify.
Okay. 2 times half. Okay, so you start. Oh, sorry, I'm coming. So 3 over okay, minus 1. 1 over 2. That's half. Is equal to.
What do I write here? What do I write here?
Please wait.
1 over 2.
Yes, 1 over 2
Mm.
is equal to um now I'm coming. Okay, 2 minus 1. Okay, so I want to cancel. Then 2 and a half
What do I write
over
over there? What
2.
do I write over there?
That's 0.
0. So the next one becomes negative B.
Yes.
This becomes 2, 2, 4 plus 1, 5 over 2.
2, 2, 4. 5 over 2.
Then make B the subject.
Yes.
So how do I
So you divide both sides by 5 over 2.
divide on? Just move this one. This one is multiplying. It's multiplying this. Just move it to the other side. So half divided by 5 over 2. Okay, as we are saying, negative B. Then equally becomes half times 5, 2 over 5. Sometimes
Yes.
when I read this number, I just use cross multiply.
Mm.
When you use cross multiply, it means you are multiplying only the element, this and this, but you maintain the B and you remove the negative 2. So negative 2 over 2 times 5 equals B, right? The 2 is moving to this side. The negative 2 is moving to this side. The 5 is at the top, the
Okay.
5 will come down. And you'll be left with only the B. Now in this and this cancels. You get B as negative 1 over 5. The value of B. Are we okay?
Yes.
Now the next one, when X is what?
When x is negative 2.
What happens?
So a is 3
3.
times, yes, negative 2 minus 1 is equal to a bracket open 2 times negative 2 minus 1 minus b bracket open, -2 plus 2, bracket close. So this one will give you negative. I'll give you -7 is equal to this time is -4 minus 1 equal to is -4a. Yeah, 4. Okay, this is 5a.
Be careful.
Okay.
Divide both sides by
And let's try this. So this one is 0. So divide both sides by half, -5. So a is equal to 7/5.
I'll come and rearrange it. 1 equals
Y is equal to negative.
you are putting the A there. The A is
Okay,
not
y
negative.
is equal to 7/5 over.
The 5 will come down. Okay. If you write the 7/5 as a numerator, the denominator will come down.
Okay. Times x plus 2 minus -1. Oh, that supposed to be positive
Very good.
over 5x 2x minus 1.
So now you're going
Okay.
to do the dy dx.
Okay.
But rearrange it. Rearrange the y in terms of indices.
Okay. So it's going to be okay. 7 7/5 times x minus x plus 2. No. Okay.
What do I write again?
Exponent -1. Oh.
Very good. Explain -1.
Minus
Exponent
my screen.
plus what?
Plus 1/5 times 2x minus 1. Exponent -1/2. -1 rather.
So now you do the dy dx.
So 7/5 minus -1. Now I'm going to -7/5 to divide. Differentiate this, we get 1. You get 1 exponent -2.
1 exponent -2.
Yes.
You differentiate the inside, it is 1. Then you multiply by the function itself.
Okay.
Before you put the -2 here.
Okay.
Take notice. The -1 comes to multiply the 7/5. Differentiate the inside, you get 1. Then take the whole function exponent -2. Okay, do the next one.
Okay, so now I'll give you -1/5. So I'm going to affect the a and the plus there. Oh.
You If you write this one correct, they'll give it to you correct. -1/5.
Okay.
No,
To differentiate this one give me 2
2.
times 2 bracket open 2x minus 1 exponent -2.
So now simplify.
So we get -7 over 5 bracket open x plus 2 exponent 2
Mm.
minus 1 bracket open 5.
Wait, this 2 is multiplying 1. So here should be 2.
Oh, okay.
Then bring a 5.
Bracket open 2x minus 1 exponent 2.
Okay. Let's go look at the solution. Fourth one. Yeah, exactly that. Well done.
Okay. Thank you, sir.
So the partial fraction
Okay.
is quite long, but before you
Yes.
understand it, you need the concept from partial fraction. So I've taught you partial fractions, so we know where we and some of the partial fractions too. There are different types of partial fractions. We have repeated factors, and sometimes you can get some partial fraction whereby the denominator is a cubic function and the numerator is a quadratic fraction.
Yeah.
I think it's okay. You can say enough for today. Then tomorrow we'll do the implicit function.
Okay.
Okay. So you take care.
Okay. Thank you.
Yes. Okay, Charlie. Have a nice day.
Okay. So you can send me the PDF.
Yeah, let me send. I'll send it to you on WhatsApp.
Okay. Thank you.